Hello, this is Jeff Boggs. We shall cover lecture 4 today, talk a bit about central place theory, and then how that corresponds to the other models of use in location theory that we've covered in the past couple of weeks. Today we're going to cover central place theory. And central place theory, here I'm going to shorten it to CPT in my notes. Central place theory refers to two similar models. So there's the model by a fellow whose last name is Christaller, and then sort of building on that is a model by a guy whose last name is Lush. And the reason I showed hexagons in the previous page or the previous slide, or in your case, the previous image, is if you're watching this, I guess, on YouTube or what have you, is that they both made use of hexagons in the way they thought about how human activity might be ideally spread or dispersed across space. And both of these guys are Germans. They're writing like before the Second World War. One it's got a sort of a dodgy history with the Nazis, and then I guess gets rehabilitated after the war. The other guy, the second one, Lush, is younger. I think he dies by the time he's 40 of diphtheria. He was did not support the Nazis and died shortly after the end of the Second World War, I believe due to diphtheria. So there is a central place theory, which consists generally of like these two very similar models, and they employ similar assumptions as well. And these are assumptions, we'll go over them in a moment, but they're assumptions about the world that, or maybe not about the world, they're assumptions that are made in the model to simplify things so that we can see what happens when we tweak or we modify a couple of things in a sort of a thought experiment. And their models, so central place theory generally is useful for explaining how urban hierarchies form, especially with regards to how different sized cities or towns or villages that you will tend to find different kinds of service specialization. So we could think of services in terms of like retail sales, but actually the service economy is anything that's not sort of agricultural or minerals extraction or timbering. That all tends to be primary sector stuff. Manufacturing and processing of raw materials is included usually in that. That sometimes gets referred to as the secondary sector. And then services is basically everything else. So if you've ever gone to a doctor, that's a service. If you're listening to this because you have signed up for Geography 2P03, that is higher education is a service sort of in this three-sector model of the economy. So if you've gone to a restaurant or you've worked in a restaurant, that is also something in the service sector. Okay. So what were the assumptions used for central place theory? The first is one you are already familiar with, is that there is a homogeneous flat plane upon which the world unfurls, right? There's no mountains, there's no rivers, there's no hills. It's flat in all directions. The second is that, and this is a new assumption, is that people are evenly distributed over this plane. So this means that there's uniform population density. Each square kilometer has the same number of people as any other square kilometer on this plane. Third, each person has the same income and they have the same consumption preferences. So if in our model we are assuming everybody smokes, then everybody smokes. If we assume that everybody eats bok choy, everybody eats bok choy. So there are no regional differences in consumption. Likewise, travel cost is proportional to the distance traveled. And this is an assumption you are already familiar with from the previous two models. So von Thunen's model operates this way, as does Weber's model, or Weber's model, if you like that pronunciation. So basically, this means if it costs me $1 to travel 1 kilometer, then if I travel 2 kilometers, it should cost $2. And if I travel 3 kilometers, then it should cost $3, and so on. Though, in the way that we're going to look at the model, we're not actually going to have any equations. So that's a change from the previous two lectures. An assumption that was in the previous two models was that people minimize travel distance, and that's one that we'll use here as well. If I need to buy milk or bok choy or cigarettes, I will go the shortest distance I can to purchase those. As we dive into central place theory, it's useful to think about how often you consume particular kinds of goods and services, right? So do you like bok choy? How often do you buy bok choy? Do you like cigarettes? How often do you buy a new pack? Do you like milk? How often do you buy milk? Do you like shoes? How frequently do you buy milk? Or not milk, sorry, shoes. And do you like cars? So, or do you need a car? How frequently do you buy a car? Do you need dental work? How frequently do you need dental work, right? So there are all these things that we consume. And in Canada, some things like medical services, you don't pay for directly. So instead we pay for those through taxes, but there's other things that we pay for directly. But whether we're looking at medical care or eggs, so it doesn't matter. So those are all examples of goods and services that we could purchase. So I want to look at, here's some items, right? So milk, clothes, and jewelry. Which one of these do you consume most frequently, assuming you like milk? Right? If you don't like milk, you're lactose intolerant, replace milk with, I don't know, soda pop or something else you like to drink, right? On a regular basis. So generally, people, if they're going to consume milk, will consume that generally more frequently than they will purchase or consume new clothes. And jewelry typically is consumed even less frequently than clothes. So by consumption, I mean in these cases, you go out and you buy this stuff. If we look at these three, cigarettes, shoes, and autos, like if you have a nasty, filthy habit that is cigarette smoking, and I've had that before, I would buy a pack of cigarettes every day. Shoes, yeah, I buy a pair of shoes maybe once every year or so, depending on when they wear out. Though again, I've gone longer periods before I had to purchase new shoes. And for automobiles, I purchased an automobile once, bought a used one once, and we bought a new one once. And I guess we bought a car off a friend. So I'm 56, so in over 56 years, I've purchased 3 cars. Though occasionally I've mooched cars off of people, or once my dad gave me a car that he had that was kind of old. So anyway, cigarettes are a thing like milk that you're going to buy frequently. Shoes and clothes you're going to buy less frequently. Jewelry, depending on the kind of jewelry, might be something that you purchase as infrequently as an automobile. If we think in terms of gas or brooms or brain surgery, if you own a car and you drive every week, there's a good chance that every week or at least every month you're going to need gas, and maybe every couple of days, depending on your mileage and how far you drive. Brooms are things that generally last a couple of years, right? So you're not going to buy those as frequently. Though if you do a lot of sweeping, or somebody in your family's a pyromaniac, or you've got a dog that likes to chew on the broom, maybe you'll purchase it a little more frequently than your average person. But you're generally not going to buy brooms as frequently as you're going to buy gasoline, right? And so by gas, I mean gasoline. Brain surgery. So hopefully you never need to consume brain surgery, but for those people that do, they at best infrequently need brain surgery, and often only a couple of times in their life, right? So again, we've got gas, which if you have a car, you're going to buy a lot of, and you're going to buy it frequently. Brooms, which, if you use a broom as opposed to a vacuum cleaner or a Roomba, one of these little robots, those, brooms, wear out every, I don't know, couple of years, depending on how frequently you sweep and other things. And then brain surgery, that's something that you may never need. But if you do, you want to make sure you have a really good brain surgeon, right? And then this last list here sort of dates myself. I remember when I used to sometimes buy newspapers, or when they would get delivered daily. Even about 15 years ago, we still used to get a newspaper, like an actual physical newspaper. And those tend to come, at least once upon a time, they came, daily or, weekly, depending on the kind of paper you're getting. Whereas a toaster, I've known people that have had toasters, the same toaster for decades, right? And then now here I have flights in this kind of third category. So, it may be that you fly more frequently than you need a new toaster. I would hope that you fly more frequently than you need brain surgery. And it could be that actually people fly more frequently than they need a new automobile or jewelry as well, right? So that, I guess, flights, the number of flights that you take, in the course of a year might actually be more than the number of toasters that you buy in a year. So this is actually a bit of a bad example here, but bear with me. So we've got 12 different goods and services that you can purchase. So flight and brain surgery are both services. Everything else is some kind of a good. And of these 12 goods, think about how far you will travel to access these goods or services, right? Now, things like milk, cigarettes, gasoline, and newspapers, people will typically not travel all that far to get these, right? They, might go to a corner store if you live in a place with a corner store. Whereas, or, you might go to a supermarket or a supermarket that's right by a gas station. Actually, you could go to a gas station for all of this stuff if it's a full service gas station, right? But you're probably not going to drive 70 kilometers to do that unless you live far out in the middle of nowhere, right? And if you do, my apologies. This middle list of clothes, shoes, brooms, and toasters are things that typically are more durable and that you will use repeatedly, right? And for those, you might be willing to travel somewhat further than you would for milk or cigarettes or gasoline or newspapers. And part of the reason you would be willing to travel somewhat further is that these things are durable, clothes, shoes, brooms, and toasters, and you're willing to look at a wider selection, right? Or maybe there just aren't that many places that have clothes, shoes, brooms, and toasters. And so you have to actually travel to where those are sold to acquire these modern conveniences. I suppose clothes and shoes and brooms actually aren't all that modern. Be that as it may. Then we've got this third category of jewelry, autos, or cars, right? Brain surgery and flights. And these are goods that are generally more expensive if you're paying for them and are going to be found in a smaller number of locations. So in the case of flights, to sort of consume a flight, we have to travel to an airport, which then takes us to another airport when we land. And so there are these nodes, and we'll talk a bit about nodes and linkages in a later lecture. But for everything in this third category, these are items that generally are harder to find just anywhere. So even if you think about, in a given location, often there'll be, many places to purchase cigarettes, or at least there would have been like 30 or 40 years ago. And there'll be fewer places to purchase shoes and even fewer places to purchase automobiles, right? So for any one of these rows, typically that would be the way it would work out. So there's a special term that gets used in central place theory for the frequency with which goods and services are sought. So there are, order is, let's stick with this. So order, O-R-D-E-R, so we have these lowest order goods, like milk, cigarettes, gas, and newspapers. These are things that we consume frequently, or the people that purchase them consume them frequently, and often will travel only a short distance to get them. In part, you only want to travel a short distance because you need them all the time, and in part, you'd only have to travel a short distance because there are lots of places you can purchase these. There's a bit of a symmetry there, or reciprocity, I suppose. Then there are medium order goods, like clothes, shoes, brooms, and toasters. So these are things that you consume new less frequently, so that you purchase these less frequently. And, they might wear out, but you'll usually get some, a year or more out of these. The last category, the way I'm divvying this up, are higher order goods and services. So we've got lowest order, medium order, higher order. And so higher order goods and services include things like jewelry, especially expensive jewelry, as opposed to fairly inexpensive jewelry you can find in I was going to say Kmart, but I don't think Kmart's are up here anymore, and they went bankrupt in the United States, or Walmart, or any kind of place that sells kind of fairly inexpensive jewelry. Here I'm thinking of like sort of pricey jewelry, like where you might get, I suppose, an engagement ring, right? And then automobiles are expensive items, especially new automobiles. Brain surgery is a rare and specialized, you require a surgeon who isn't just any kind of surgeon, but they're a brain surgeon. And so those kinds of skills are rare, and the number of people that need brain surgery is relatively small. And if you had to pay for it, it would be super expensive. Flights are also an example of higher order goods, but we could have highest order goods. I haven't bothered to kind of work that out. And in the original central place theory, these lowest order, medium order, and highest order categories were actually broken into, I want to say, for Christaller, there were about 6 different categories, maybe 7. And then for Lush, he came up with about 150, which, is good for him. But for our purposes, we just want to sort of think of these. There are some things that you consume a lot and that you don't actually, and they don't cost very much, but you will frequently consume those. Those are examples, or those are all characteristics of kind of the lowest order goods and services. Medium order goods and services are things that you only do maybe once a year or a couple of times a year. So if you go to the dentist regularly, like at least twice a year to get your teeth cleaned, we might stick dental care, dental hygiene into this medium order category. And then higher order goods and services are those which you consume very rarely, and that frequently these things, but not always, frequently they last for a relatively long time. Okay, let's go on to the next slide. Okie doke. Let's move on to 2 important concepts, and hopefully I will go through these much more quickly than the previous slide. So these important concepts are range and threshold, and they have particular meanings in central place theory. So before we talk about what these mean, remember that one of the assumptions of central place theory is that population density is uniform. If one area has 2 people per square kilometer, then in our model, every location has 2 people per square kilometer. So keep that in mind. There are more sophisticated versions of the model that allow these to vary, but we're starting out as always with sort of the basic model, and then we work from there. So remember that as I talk about range and threshold, we assume that, if I travel 5 kilometers in each direction, like in one direction, that as I travel that distance, each, square kilometer that I pass through is always going to have the same population density, or said another way, they're going to have the same number of consumers per square kilometer. And also, one of the assumptions was that there's no regional variation in preferences. So everybody has the same preferences as well, and the same income. So bear that in mind as we talk about range and threshold. So range is basically, it's the distance that people are willing to travel to buy a particular good or service. You can think of this as demand, I suppose, though there are things called spatial demand cones that you can use to teach central place theory. We are not going to do that. But if you go online and look up central place theory, they will, some sources online will make use of sort of a revamping or a modulation, if you will, innovations on central place theory by regional scientists in the 1960s, and they'll talk about spatial demand cones, and they'll actually talk about spatial supply. Did they call those cones as well? Anyway, but we're not going to do that. So threshold. So the threshold is the minimum hinterland or the area that's needed to support a provider of a given good or service. So if I sell newspapers and milk, I'm going to need a certain number of customers just to break even, right? The area that includes that minimum number of customers I need, that is my threshold in this context, right? And this gets at supply, right? So how big of an area does somebody need to break even when supplying a particular good or service? That's what threshold captures. And different goods and services are going to have different ranges and thresholds. That's probably pretty obvious if we think about it in sort of plain English. I'm not going to travel 200 kilometers for milk in the current environment. I can imagine some fantastical case where maybe I would do that, but right now, no, I'm not going to do that. So I will go to one of a couple of places that are close by, and honestly, even if there's price differences, I may be lazy and just go to the closest place because it's the closest, and I don't want to waste a bunch of time because milk is not very expensive. So at least at this stage of my life. Okay, let's go on to some other things. As you may or may not recall, the previous slide was headed range and threshold. So ranges and thresholds result in what Christeller referred to, when we translate it, referred to as central places, which is in English kind of a dorky name. In German, it's kind of a dorky name too. But it's kind of a term that Christeller, who was the first central place theory guy, it's a term that he uses to refer to all kinds of places where you can acquire goods or services, regardless of whether they're low order, medium order, or higher order goods and services. So central places is like the generic umbrella term, right? And so settlements provide these central goods and services to surrounding areas. And so in his model, these settlements are basically just points, and they don't actually have more people in them. That just happens to be the place where a particular good or service is provided, right? And so the hinterlands, that's all the places that aren't central places in this model, they have to go to these central places to get milk or sugar or lemonade or whatever it is they want to buy. Or diamond rings, right? So whatever it is, whatever the good or service is, a university education, elder care, doesn't matter. You've got to go somewhere to get that. And one of the trippy things, one of the weird things that arises out of this model is that if we assume that there are points where you can get particular kinds of goods and services, and that actually there are different kinds of points where you can get higher or lower order kinds of goods and services, it creates this trippy geometric pattern with hexagonal retail sheds. So a retail shed is basically it's almost like, I suppose it actually is the threshold. So a retail shed in modern retail geography is corresponds to the area around which that exists or that supplies or provides customers to a particular store, right? So if I've got a shoe store, my customers come from typically a, somewhere, a certain radius, if you will. Also, at this point, these are models that were created long before the internet when people could just order tons of stuff, all kinds of wacky things on the internet. So there were mail order catalogs that existed when these models were created, but it was not the same world that we live in now. So frequently, if you wanted something, you couldn't just go online or pick up your phone and call for it, though actually in some cases you could call and then have a delivery the next day for things like milk, when there were milk men who would deliver milk, right? So, or butter. So a thing to remember is that all of these models assume that the consumer has to go somewhere to get the thing that they want. Nobody's going to bring it to you in these models. Okay, so a hexagon is a six-sided shape. I'll show you some in a minute, and actually the very beginning slide had a whole bunch of hexagons on it, but we'll come back to why hexagonal retail sheds form in central place theory. And some of these retail sheds are going to be bigger than others, right? So if I sell diamond rings, usually most people buy, if they buy diamond rings at all, they're going to buy them only a couple of times in their life. Okay, maybe somebody is like one of these people who gets married and divorced like 8 or 10 times in their life, which then drives up the average for people, like for the actual number of divorces. But those people are to some degree outliers. Most of the time, if somebody's going to buy a diamond ring, they might do that a couple of times in their life. Whereas, if you are not lactose intolerant and you drink milk, a lot of time you will go, every week to get a bag of milk because we're in Canada. So we've got these crazy bags that burst, which is super annoying. That's a different story. Anyway, with these retail sheds, some cover a larger area, and the ones that cover larger areas correspond to higher order goods. So things like, automobiles or brain surgery or diamond rings will tend to have larger retail sheds or larger thresholds because they need a minimum number of people to make performing those either operations or providing those goods to make that economically viable. So for the retailer or the provider to break even, right? And for lower order goods, their retail sheds will tend to be much smaller. Let's say a bit more about range and threshold. So here we have a pair of circles. One is threshold and the other is range. Thresholds will tend to be smaller than range. And thresholds you can think about this as sort of it captures, the supply of a particular good or service. Like it's really what's the minimum area that's needed to support whoever is supplying this good or service. And so remember that this minimum area, it's going to have some number of people in it. And in this weird model, each area, each hectare, if you will, or each square kilometer will have the same amount of people. So that is, there's a uniform population density. So we've talked a bit about threshold. Okay, range. As this range increases, and remember that range is a way to get at the demand for a particular good or service, and the range is really the distance people are willing to travel for a specific good or service. So often people are willing to travel further so that their range is going to be further than the actual threshold that is needed to provide that good or service. You'll recall that a few slides back, I said that this model produces hexagonal structures. Let's talk about that. So that another way to think about this is that when we think in terms of like goods and services, that there are patterns of, that there are thresholds, the minimum area that is needed to allow a particular good or service to be provided. So that area, as well as the distance that people might be willing to travel, so the range, that often these get kind of distilled down into these funky shapes that are hexagons. So hexagons have 6 sides, right? 1, 2, 3, 4, 5, 6. We could make some other shapes out of all of this, and if you look at this pattern too long, it can put you in sort of a strange state. So we won't look at it for too long. Oh, dang nabbit. Here, let's, there. Okay, so the reason that we have hexagons has to do with, you'll remember in the previous slide that when we were looking at range and threshold, that we drew those as circles, right? So we can use a compass, a drafting compass, that is, to make circles. It's possible that you might have used these in high school. I don't know if they still actually use these or not. They're totally cool. They let you draw a circle of varying sizes. So there we have a circle. And you'll notice that this circle, I've centered it on one of these dots. That dot is, we'll think of that as a central place, right? This is central place theory. You'll recall that central places are it's kind of an umbrella term for all of the different kinds of places that can provide goods and services, whether they're the lowest order goods and services or the highest order. So remember, central places is the term for each of these dots. And so this dot, it belongs to a lower order central place relative to this dot. And it's like a giant Matryoshka doll. However, we don't actually have, you'll have to look in your textbook to see more elaborate versions of like just how crazy these hexagons get. So, but for now, we can think of this spot as that's for lowest order goods. And then actually we've got this one over here. So then that might be middle order goods or goods and services. And then this one could be higher order. And then if we think about sort of all of these together, 1, 2, 3, 4, 5, 6, 7. So all 7 of those. We could actually also draw a hexagon using those, that then this central area would be, even though it's not here, we could make an even bigger, fatter circle there to sort of identify that as the place with the highest order goods and services. But I'm getting ahead of myself. Let me step back. So why hexagons? So one of the reasons we have hexagons in this model is that if we draw a circle to represent, this is, if I'm a person and I'm here, or actually if I'm a person and I'm here, the furthest distance I'm willing to travel is the edge of this circle. Though it gets a bit weird also in that, we're assuming that each area has the same population density, so it doesn't really matter where exactly we draw these circles, but you want to draw them so that their centers are always sort of equidistant from each other. Okay, I'm yammering on too much. So we draw the circle. So, and this tells us the maximum distance people are willing to travel for the same good or service from a central point. So if I'm here, then I'm willing, if this is sort of the range, my range for milk, then I'm willing to travel, this far. And actually, maybe I'm willing to travel even further, but for now, we'll just go with this. And if we draw more circles that are kind of equidistant apart, so we've got this point, let's draw another circle. So we can put one up there. And so all this time, we're imagining we're using one of these drawing compasses. So we've got one up there. And then we draw another one over here. And so the distance from here to there is the same as the distance from here to here. So when I say equidistant, that means that they're, an equal distance from each other. Also, this one is the same, like this distance and this distance and this distance, it's all the same. And we do it again, right? And so that distance from here to there is the same as all of the other distances. Again, again, and again, right? And you'll notice that there's this weird overlap between these. And so this is actually one of the kind of cool things about doing this by hand, is that you get to see sort of how these geometric patterns emerge from just circles. Anyway, now we have these 7 circles. We have the overlaps. Oh, let me get my little laser. We've got these overlaps, right? And the next stage is that we draw lines along each pair of overlapping points. So we go from here to there, from there to there, from there to there, there to there, there to there, there to there. A bit like this, though I didn't actually trim these lines. So we've gone from that point to that point, and we've drawn a line between them. Though optimally, I would chop it off there and there. And then we do it again over here. So from that point to this point, and then from this point to this point, and then this point to this point, that point to that point, that point to that point. And so if you look closely, this forms a hexagon, which is a little bit wonky because my circles aren't precisely laid. But you see how we can generate these hexagons from these circles, and that these circles in turn correspond to the range people are willing to travel to get something, let's say milk. And just to sort of put a point on it, to bring this to your attention, if this is where I live, I'm willing to travel all the way over to here, or all the way over to here, or up to there, you know, just because I'm willing to travel, to the other side of that red line if I'm minimizing the distance traveled and I'm, anywhere, you know, inside this hexagon, this central point is going to be the place where I'll go to get the good or service, in this case, milk, right? And just to hammer home the point, that's how we get these hexagons from circles. We could also repeat this procedure for each set of higher order goods and services. So we could start with the lowest order goods and services, which we had here. We can move up to the next level, so on and so on. So we could end up with, you know, whatever level that is. We draw our circle. It would roughly correspond to, well, one of these points should sort of be underneath that. So we've got one here, we've got one there, we've got one there, we've got one there, there, and there. And there we have that pattern again, right? So if we drew lines between, that point and this point and that point and this and that, that and that, and that and that, we would get another hexagon. Here we have a diagram from Christaller's original work. And it shows us a couple of different, so we've got hexagons of this size, we've got hexagons of that size, and then we have even larger hexagons. And then actually we have what are called here auxiliary central places that hexagons were not drawn around, but could have been. So this gives us an idea of sort of how these hexagons nest with each other in an overlapping fashion. One of the reasons I'm not having us do this manually is that this can take a long time. And I think that sometimes it's useful to have students work through models by hand, and other times it's just more efficient to say, here's a picture, let's think about how this picture was created and what it means, as opposed to sort of diving into the math behind it. One of the points of this slide is that for lowest order central places, which would actually correspond to this P4, that basically whatever goods and services are found at lowest order central places, let's say that you can buy, some milk and bread and a newspaper at these lowest order central places. So here and 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 there and there and there and there and there and there, and you get the picture that all of those places you're only going to be able to get, what did I say, milk and bread and newspapers. However, each of the next order, like as you kind of move up this order, move up this rank, move up the urban system, as you move up to the next sort of a larger node, if you will, the next higher order central place, it will disperse, or it's the kind of place where you could get additional things that you couldn't get at these smallest locations. But you can also get this stuff from the smallest locations. So let's say that these kind of P3, that's the place where you can get, I don't know, fresh meat and vegetables. And yeah, fresh meat and vegetables. We'll stick with that. So, which you might not consume as frequently as you consume milk and bread and newspapers. But in addition to being able to get in addition to being able to get meat and vegetables at these locations, you're also going to be able to get all the stuff that was available at the P4, at this auxiliary central place. So here you can get extra stuff that you can't find here. But you can also get the stuff that's found here. So as you move up this order, these locations have a wider range of goods and services. This circle here is the P2 circle in this model. So it still says lower order central places. And actually this can't be from Christaller because it's in English, but I think the image is taken originally from Christaller, translated over. That's beside the point. So let's go back here. So at this P2 location, you can get whatever could be found at the P4 location and whatever is found at the P3 location, plus whatever things are only found at the P2 location. So, maybe that's brooms and shoes and clothes, right? And what that means is that this big hexagon here, the whole thing, that all of that area is the size you need to actually be able to sell or to provide brooms and shoes and what was the other item? Brooms, shoes, and clothing, right? Because people don't buy those as frequently, but they're willing to travel a longer distance to get to that, right? And then P1, sticking with our previous examples, this would be the place where, in addition to getting all the stuff you can get at P4 and P3 and P2, P1 also serves this whole big hexagon, with automobiles and maybe passenger flights and jewelry and brain surgery, right? All right. So again, lowest order central places like milk, bread, or in this example, gasoline, are found, all over the map at not just, so the goods and so that these P4 locations provide, milk, bread, and gas, but actually this P3 location here will also, in addition to providing milk, bread, and gas, will also provide meat and vegetables, I believe is my example, right? And it works its way sort of up the system. So I believe that was the point of this slide. So yeah, that every central place sells the lowest order goods just beneath it, as well as whatever new goods and services they sell that are only available at the current higher order that you're located at. Using this same illustration, this same diagram, higher order central places, and so here in this, the P1, 2, 3, and 4, P1 is really the highest order. These kinds of goods and services, so from earlier we talked about brain surgery, automobiles, jewelry, and passenger flights, that these locations, so here we've got, I use brain surgery, that the only place you're going to be able to get brain surgery is at a P1 location, right? And very few places provide the highest order goods and services. So as we move up the urban hierarchy, as we uh, go from central places that are lowest order up to middle order, up to higher order, up to the highest order, there are correspondingly fewer and fewer of that kind of central place. So these nested hexagons, they generate an urban hierarchy. And imagine those smallest hexes that we looked at, that we then turned into larger and larger hexes. And when I say hexes, I mean hexagons. So these hexagons, if we imagine the smallest hexagons, we can imagine that the smallest hexagons correspond to the minimum threshold needed to support, fairly commonly demanded goods and services. Whether it's, milk or cigarettes or newspapers, right? And then settlements. So, we could, instead of saying like P1, P2, P3, and P4, we could just give them actual names or more clear names. So like we might imagine that the P1 is the equivalent of kind of the things that you would find in a village. And those would be on this landscape of crazy hexagons would be the most common. And then we can think, and it would just cover that one hex, right? It would just, the middle of that hex is, where the goods and services you might find in a village would be available. For a town, that's a hex or a hexagon that's going to be surrounded by 6 other hexes, right? So there's the one in the middle and then the 6 around it. And in that, it's, if there, are 36 villages, then there would just be 6 towns. Sort of using the ratios and the logic here. And we'll find, whatever the P2 goods were in this case. Here, then we've got, cities, which could correspond to sort of the P3 order of places. And in our hexagonal landscape, these would be relatively rare. And the hinterland of the hex that had the city in the middle of it, its sort of hinterland would be the surrounding 36 hexes. And, for a metropolis, so maybe cities are places where you can get fancy diamond rings and flights, whereas a metropolis, which is often a lot of cities that have grown together or one really large city, that, maybe the metropolis is the only place where you can find world famous brain surgeons. And so those would be relatively rare. And their hinterland or their threshold would be, the 216 hexes around whatever hex contained the metropolis. Though these terms get kind of weird because in this crazy model, we're assuming a uniform population density. And these terms then don't refer to the number of people found in those places, but instead the kinds of goods and services that you might find in one of those uh, kinds of places, which honestly is a bit difficult to wrap your head around. All right, let's go on to the next one. So far, we've talked about Christaller, and I can't remember his first name, but the other central place theory guy was August Loesch. August is spelled like August, the month. So Loesch sort of expanded on the ideas of Christaller, and I just want to touch on a couple of his expansions. So one was that whereas I think Christaller had maybe 7 orders, so from like the lowest order to the highest order within his system of central places, Lush had about 150, as I recall. And so he got really finicky or creative. I guess there's different ways to look at it. That, he recognized that for butter, there's a different shed or a different threshold and also a different range than for milk. And for example, so if you buy milk, you might go through milk faster than you go through butter. I suppose that depends. Um, anyway, his notion of central places just became much more refined. But as a result of that, his maps of hexagons would be even more busy or detailed because instead of having like 7 orders, if you will, or 7 kinds of central places, he could have up to 150 kinds of central places, which then just becomes an utter nightmare to actually look at the hexagons for those. But as a result of that, one of the things that happened was that, at least with his model, it results in some differentiation in the landscape, and that you have essentially chunks, these sort of sectors, he called them. So, and they kind of end up in like this kind of pattern. Oh wait, you can't see where I'm pointing. So it ends up with sort of this kind of pattern. So up here, we can see that, if we draw like kind of pie slices narrowly enough, that some of these pie slices would have more central places in them and some would have fewer. And, here's an example that just has one, two, looks like maybe 3 different kinds of central places. Whereas, if you have 150, then you start to see areas that are going to have relatively more central places, or sectors, if you will, that'll have relatively more central places, and then some that'll have relatively fewer. And so that's what this is supposed to capture, which was novel in so much as it started to look more like reality. I mean, he still, in the basic model, had some assumptions about uniform population distribution, blah, blah, blah. But with this sort of by adding more kinds of central places, when you stood back and you looked at your hexagons, and if you had 150, that means that some of them would be teeny tiny if you drew them, and some would be humongous, maybe, I don't know, the size of your yard or something, right? Anyway, one of the, I guess, the saving graces of this, or the reason people thought this was important, is that he begins to sort of extend on the original central place theory work. All right, I'll kind of leave it at that. So, okay, the past couple of weeks we've talked about location theory, which is really a bundle of models that are informed by uh, at least four models that we've looked at. So, and you'll notice up here I put location theory in not parentheses, in quotation marks, to kind of help you remember that this is a particular definition of location theory that has existed for quite a while, and it contains sort of at its base von Thunen's land rent model, right? So that was the agricultural model we looked at, which generates a landscape with concentric rings. There was Weber's model of industrial location, and when we solved for it, we solved for the triangular case. So there were two raw materials, a factory and a city, which was the final market, right? There was Christoller's model of service location, which we just looked at, and then Lusch's model of service location. So together, these two generally get lumped together as central place theory. So, but they are, two related theories. So Christoller was first, Lusch was second, but they lived sort of at the same time. The Lusch died at a much earlier age and was not a Nazi. Anyway, yeah, so this is when people talk about central place theory, they often kind of rub or ground or dump these two models together because they're very similar. And then actually in the 1960s, there were versions of central place theory that made use of something called spatial demand and spatial supply cones, which was the way that I originally learned this. But I think going at it that route sort of is more detailed than we actually need. Okay, and actually also with location theory, there are occasionally other models that get brought in. There's one, I love the name of this, Hotelling's ice cream model, I believe is what it's called. Yeah, Hotelling's ice cream model. And so in that one, so Hotelling is not a German, so he's some American dude, if I remember correctly. And in this model, you've got two people that are selling ice cream on a beach, and you assume that the beach is about the same width, its whole length, and that along that beach, there are always the same number of people, every couple of meters. So basically it has uniform density. And, the question is, if you sell ice cream and somebody else is selling ice cream, what kind of dynamic emerges? And so generally what happens is that the ice cream stands will move to the middle of the beach, because that way they each get, they both maximize the number of customers that they'll have access to, while also not surrendering anything else to their competitor. So that is actually an interesting location theory model as well, but your textbook doesn't cover it. And if you want to know more, you can kind of look it up, or come to my office and I'll draw you a diagram. So, okie doke. So location theory. And here I'm attempting to kind of help you compare and contrast. What binds these together? How are they similar and how are they different? In the next few slides, I then would like to compare and contrast these location theory models that we've covered in this class. When we compare and contrast, we usually look for, on the one hand, similarities between things, and on the other hand, differences between things. So let's think about the similarities between kind of these three sets of models. So we had von Thunen's model of agricultural land rent, we had Weber's model of industrial location, and then we had central place theory, created by Christaller and then modified by Lusch. So what similarities were there? All of them incorporated distance as a key variable. So in central place theory, we didn't get to see this work out as well because we didn't run any equations. But you still, with this notion of both, threshold and range, those get at distance, right? And in the other two, so in von Thunen and in Weber's models, location is explicitly incorporated into our equation. They also incorporate many of the same simplifying assumptions. I mean, that is one of the, I guess, from a teaching and learning perspective, or as a student, I often found this helpful, is that they all depend upon the same somewhat dodgy set of assumptions, or maybe not identical assumptions, but they share a lot of the same assumptions. So they have those similarities in common. And they all have solutions in the general sense of, if we think of the solution as, what does the landscape look like, under these models? If we think of that as, the solution is the geometry, I suppose, where are things placed is another way to think about that. Well, they all incorporate transport costs somehow. Some more explicitly than others, but even in the term, in von Thunen's model, transport costs, they vary with what you're shipping, right? Do they? Yeah, they do. So in so much as the some things are easier, some things survive shipping more easily than others, right? So that's kind of incorporated into that cost. Likewise, with Weber's model of industrial location, some things are more costly to ship than others, for the same kilometer distance. And then in central place theory, these transport costs are incorporated in the sense that people are only willing to travel so far for whatever kind of good it is or service it is that they're looking for. So, after a certain distance, people will just say screw it and will not travel to get the thing. So, what then are the differences between these models? So here we've got a handy table to help us think about this. So here I've got model, and it's just, who's the author. So von Thunen, Weber, or Christaller, and Lusch. So this is von Thunen's land rent model. Oh, wait. Let me get out my little pointy laser thing. So von Thunen's land rent, agricultural land rent model, Weber's model of industrial location, and Christaller and Lusch's central place theory models, which, if we think in terms of like what sector of the economy do they correspond to, it's kind of obvious from the titles of the first two models. Let me step back for a second. So sector in this sense here doesn't refer to a actual location or an area. Instead, a sector of the economy is used to think about, is it the primary sector, the secondary sector, or the tertiary sector. So the primary sector is things like agriculture and resource extraction. By and large, that's pretty much the primary sector. The secondary sector is manufacturing. So it's either the creating of things from parts or the processing of raw materials into intermediate goods or parts that can then be assembled eventually by somebody else into a finished product. And then the service sector is pretty much the rest of the economy. So that's everything from retail to government administration to any kind of education to healthcare. Those tend to be the big examples. Warehousing often fits in there. Transportation usually falls into the service sector as well. All right, so that's what I mean by sector. If we think about von Thunen, well, that's a model of agricultural land rent. That's part of the primary sector. Weber, it's Weber's model of industrial location. Industrial in that sense means manufacturing, right? So in the examples we had in class, and we were making screws or nails. I think they were nails, out of iron ore and coal. So we had to get the iron ore from the iron mine. We had to get the coal from the coal mine. We had to ship them to a factory. And then at the factory, the iron ore was smelted and then, using coal to heat it up. And actually, we left out some steps, but we'll kind of leave it at that. And then, the molten metal was poured into forms to make nails that were then shipped off to the city or the final market. And then with Christaller and Lusch, we had various examples of goods and services that are being sold often from retailers. But, I did talk about brain surgery, which is a health service, I suppose, and flights, so passenger flights, which would be the transportation industry, which would fall in here as well as services. And those, are the tertiary sector. So the primary, the secondary, the tertiary sector. I mean, that's kind of a nifty thing about these three models is that they cover different sectors of the economy using many of the same dodgy assumptions. If we think about the kinds of origins and destinations that they incorporate, this helps us think about also distance, right? So remember, distance is something that they all use as a kind of a key variable. But what is it a distance of? And it's a distance of, or from an origin, so a starting place, to a destination. So usually the final market, at least in the first two cases. So, in von Thunen's model, it's basically the origin is like a point or, some parcel of agricultural land. And here I use quotation marks around agriculture or agricultural because I included things like charcoal production, which is not often nowadays thought of as a kind of agricultural production, but it is a kind of, sort of a, that does tend to fall into kind of primary activities or, the primary sector. So, okay. And then with Weber's model, we've got a couple of different sites. So in the models that we looked at, there were raw material sites, and then there was a factory. And that, so in terms of the origins, right? So where would the trip start? That's a way to think about origins. So where does the trip start? So the trip to the market. And so, in the ones the example that we had for Weber, there was coal and iron ore mines. So there were two different raw material sites, and then that coal and iron ore were being shipped to a factory, and then this factory, uh, you know, on the one hand, we'll see that it can be a destination, but then the factory ships stuff to the final market or to the city. And so in a way, it's a sort of an origin as well. And then for Christaller and Lusch's central place theory, we have the origin is it's basically where do people come from when they're going to go, the people that want to buy milk or that need brain surgery, they have homes in some kind of hinterland. And in the model that Christaller and Lusch come up with, like their variations on the model, the hinterland gets kind of really split into, ranges, which is sort of the distance that a person is willing to travel to get milk or brain surgery, and those are going to be different distances. And then there's thresholds. And so thresholds are the kind of area that's needed to support a particular provider of a good or service, right? And then in terms of destinations, so, for Von Thunen, the isolated city, that has the city as the final market. So remember, the middle of all of your concentric rings is where the city's located. So for Weber, the destination is either going to be the factory. So if it's raw material sites, they're shipping stuff to a factory, or if your origin is the factory, then the city is going to be the final market, or the city is going to be the destination for those trips, right? Or so those distances, right? So from here, from the factory to the city is a particular distance. From a raw material site to the factory is another distance, right? Okay. And then for Christaller and Lusch, the destination is just the nearest central place with whatever the desired good or service is, right? So you've got people that live in these homes, and you have the same amount of people per square kilometer. So it's always going to be the same number of people, willing to travel to the nearest central place for whatever the desired good or service is. Okay, then what kind of weird geometric patterns can result from these? So with Von Thunen, it has these concentric rings, and each ring corresponds to a specialized zone of agricultural production, right? Or primary sector production. So in class, we had cassava, we had charcoal, we had guinea pigs. So, there's a particular geography that emerges, a geography of specialization in that model. With Weber, the factory gets located in somewhere between the raw material sites in the city. So in that example that we used, I talked about this is a triangular solution. We had two raw material sites and we had a final market, and between those three sites, we needed to locate our factory. We could have had 5 raw material sites and a final market, and then we would need to locate our factory somewhere between those 6 different locations. The math for that is basically the same as what we've already done with the 2 raw material example, except we just add some more raw materials in there. But actually having you do that the way that I did it with the circles, and it becomes a nightmare. So, but the resulting pattern with Weber is that basically, you figure out what are all my raw materials, and then where's the final market for whatever my factory is going to produce. And your factory is going to go somewhere, and whatever weird shape is, defined by, within those points. And then with Kristeller and Lush, you end up with hexagons that are formed around each central place, and it creates these sort of nested, overlapping hexagonal structures that, are kind of remind me of beehives sometimes. Okay, so those are some of the differences. You might also think about, what are they solving for? So in the case of, von Thunen, it's land rent, uh, or actually, sorry, it's total transportation cost. Actually, that's Weber. That's total transportation cost. Though with von Thunen, you're solving for land rent. So that's really the amount of money that the landlord is going to extract from the farmers, right? For Weber, then that's total transport cost. And for Kristeller and Lush, the model doesn't, I find it hard to kind of classify in the same way uh, in terms of just like a simple everything equals something. There's not one equation, just one equation that sort of sit behind Kristeller and Lush. So I kind of left that out. Okay. I think that might be everything. If this is the last slide, I wish you a happy day or evening or whatever time it is for you. And yeah, I'll talk to you later.